Okay, next I'm going to do problem 13.13. What I'm going to do is, since this is so similar to the other hypothesis test we did in 13.12, we're going to point out the differences between this problem and 13.12 in terms of the hypothesis test, and we'll work through the confidence interval here in a second. So 13.13, first off, I'm telling you that this problem you should assume the variances are unequal. Okay, so that implies then that, same thing as saying that the population variance of population 1 is not equal to the population variance of population 2. And as I said earlier, that for those situations, I'm going to give you the degrees of freedom. In this instance, the degrees of freedom are infinite. Okay, so that's the one difference. Don't worry about the degrees of freedom. I'll tell you that for unequal variances. Second big difference is the calculation of the test statistic. And so here, formula is, again, this will be provided to you on the exam, difference in sample means minus the hypothesized difference, divided by the square root of the sample variance from sample 1, divided by that sample size, plus the sample variance from sample 2 divided by its sample size. So I plug in the values here. Again, the values come from the appendix for the sample statistics. And you'll see that sample mean of sample 1 is 58.99 minus the sample mean of group 2 minus hypothesized difference. Again, in this question, we're just testing whether there's any difference. So that is going to be a 0 there. And then finally, the denominator. Again, we're told in the question the value of S, 30.77, the standard deviation. We have to square that to find the variance for that formula, divided by 250 plus, again, that variance divided by 250. And the result you come out with is 1.79. Okay, you'll find that that does not, I believe, fall in the rejection region, so you're going to fail to reject it at 95%, I'm sorry, at the 5% significance level. Okay. So again, that's just the main differences. I'm not going to work through the entire problem. But what I do want to work through, though, is the confidence interval. So I'm going to do now letter B. We're looking for a confidence interval for mu1 minus mu2, and the confidence level we're to use is going to be 95%, I believe. Okay, so a 95% confidence interval for that difference. Well, we said that the formula for this is going to be our point estimate, well, the difference in sample means, plus or minus scaling factor, 1 minus the confidence level, divided by 2, to worry about degrees of freedom again, since we're dealing with the t-statistic, and times the standard error of that difference in sample means. Okay. Well, difference in sample means that value is just going to be sample mean for sample 1 is 58.99 minus the sample mean for sample 2, 52.96, and that difference is going to come out to 6.03. Okay, so we know our point estimate. So the next term we need to worry about is our scaling factor. I've gone ahead and written down the first part of this. It's going to be a t-statistic. Again, that's our type of distribution. And I was a little lazy earlier to not note that, again, we have independent samples in this problem. And secondly, that we have an unequal variance, so we have to use the unequal variance formulas. So confidence level is 1 minus confidence level here is 95%, so this subscript is going to be 1 minus 0.95 divided by 2. Degrees of freedom are infinite, and I told you that a second ago for this problem. That's going to be a t-statistic with 0.025 probability with infinite degrees of freedom. And if we go to our table here, that value is 1.96. Okay, so our scaling factor here then is 1.96. Our last step that we need to worry about is the standard error. Someone was trying to walk in my classroom and interrupt my filming session, very rude. Standard error here is going to be the square root of the first sample variance divided by the sample size plus the second sample variance divided by its sample size. We're going to plug in these values here. First problem, we know that that's going to be 30.77 squared over sample size of the first sample is 250 plus sample variance for the second sample is 43.32 squared over that sample size, which is again 250. You calculate that out, that's going to come out to a number, which I don't have in front of me. Okay. So what this is going to end up with is we're going to plug this down to our formula. Our value is going to be 6.03 plus or minus 1.96 times this what I call number, which again, I apologize for not having in front of me, but it's that number right there, the standard error of the point estimate. And when you do that final calculation, it's going to be 6.03 plus or minus 6.59. That ends up with lower bound is negative 0.56, upper bound is 12.62. And that concludes this question with another person trying to walk into my classroom.